Thévenin circuit is composed of an ideal voltage source in series with an impedance. A Norton circuit is composed of an ideal current source in parallel with an impedance. Both circuits are equivalent to each other, which is to say, looking into terminals A and B, you could not tell the difference between the two circuits. There are three rules you need to know in order to switch between the two circuits. First, the Thévenin impedance and the Norton impedance are the same. Second, a Thévenin voltage is a Norton current multiplied by a Norton impedance. And the last one is a Norton current is a Thévenin voltage divided by a Thévenin impedance. In this example, we'll show how to convert this circuit from its Thévenin form into a Norton form. This box is the Thévenin impedance. The Norton impedance will be the same. Our equivalent Norton circuit is about 890 milliamps at a phase angle of about 27 degrees, with the same impedance as the Thévenin circuits. In this case, 10 minus J5. We calculated the Norton current as the Thévenin voltage, which was 10 volts phase angle 0, divided by the Thévenin impedance, which was 10 minus J5. In polar form, it's about 894 milliamps at 27 degrees. Personally, I prefer to put voltages and currents into polar form because that's what the meter would read. To make things more interesting, let's build this circuit and see if we can determine the Thévenin impedance. Now remember, Thévenin works for any two-terminal source. One easy way to solve this circuit is to take each Thévenin piece and convert it into its Norton form. Now we've already done that to the one on the left. That should look familiar. Now we can do it to the one on the right. This Norton form is much easier to deal with. We see we have two current sources that are in parallel, and we have two impedances that are in parallel. We can go ahead and combine those. This takes care of the impedances, and this takes care of the current sources. When we put that together, we end up with a circuit that looks like this. We can now take this Norton circuit and convert it back to Thévenin. A Thévenin voltage is a Norton current by a Norton impedance, and the Thévenin impedance is the same as the Norton impedance. One final step, we sketch out our circuit, and we are done. Looking in, this circuit is indistinguishable from our original.